Greetings again everyone, welcome back to my channel. Here we have another mathematical equation that we're going to solve, where in this case we have a pure simultaneous equation where one equation says x plus y is equal to 5 and the other says x times y equals 25. And we are to find the values of x and y. Now you may want to save this video for future references as we're about to solve this pair of simultaneous equations. You may also take the time out to check out my playlist and how to solve other simultaneous equations like these ones. Alright, so here we go. Our first equation says x plus y is equal to 5, so this is equation 1. And our second equation states that x times y is equal to 25, and this is equation 2. Now to solve this pair of simultaneous equation, we use what we call the substitution method, where the value of one variable in one equation is substituted in the value of the variable in the other equation. So in this example, we'll be substituting the value of y in equation 1 into the value of y in equation 2. So then we will now have x times the value of y, which is 5 minus x, and then we have that equal to 25. And now from here we expand our brackets by saying x times 5 gives us 5x and x times negative x gives us negative x squared. We have that equal to 25. And then now from here we can refactor our equation having our x squared at the front. So we'll have negative x squared plus 5x equals 25. And then we can take the 25 and bring it over to the left hand side of the equation. So that means we'll have negative x squared plus 5x minus 25 is equal to 0. So here we have what we call a quadratic equation where we have the values of a, b, and c. Since the value of a cannot be negative 1, we divide our equation by negative 1. So we end up with x squared minus 5x plus 25 is equal to 0. Now we go from here by solving x, and we use what we call the quadratic formula, where x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Where in this case the value of a is the coefficient of x squared, which is positive 1, and the value of b is negative 5, and the value of c is our number term, which is 25. Now plugging in the values of a, b, and c into a quadratic formula, we have x is equal to negative, and in brackets we have negative 5 plus or minus the square root of, now b squared will be negative 5 squared, and then we have minus 4ac will be 4 times 1 times 25. And we have all of this over 2 times 1. So now evaluating this, we know we're going to have positive 5 plus or minus the square root of negative 5 squared is going to give us positive 25. So we have that subtract the value of 4 times 1 times 25, which gives us 100. So we have 5 plus or minus the square root of 25 minus 100 all over 2. Now we can rewrite this as 5 plus or minus the square root of negative 75 all over 2. So then from here we have x is equal to 5 plus or minus the square root of 75 times the square root of negative 1. Now let us look at the factors of 75. In this case we're going to take 25 and 3. In the next step, we're going to be using this to simplify for our solution for x. So then from here we have x is equal to 5 plus or minus the square root of 25 times the square root of 3. And we will also have this times the square root of negative 1. And again, this is all over 2. Let's not forget that. Now from here we can simplify our solution as follows. We'd have x is equal to 5 plus or minus the square root of 25 is 5, so we'd have 5 times the square root of 3 times the square root of negative 1 all over 2. Now the value of the square root of negative 1 is represented by the symbol I, as the square root of negative 1 is an imaginary number. So then this leaves us with the solution of x being x is equal to 5 plus or minus 5 times I times the square root of 3 all over 2. So with this we'll have two solutions for x. So we'll have the first solution for x being 5 plus 5 times I times the square root of 3 all over 2. And for our second solution for x is equal to 5 minus 5i times the square root of 3 over 2. So now that we have both solutions for x, it's time to solve y. So we'll have y is equal to 5 minus x. So we'll have the first solution of y being y is equal to 5 minus the first solution of x. And for the second solution of y is equal to 5 minus the second solution of x. So we'll have y is equal to 5 minus the first solution of x, which is 5 plus 5i times the square root of 3 over 2. Now to solve y, we need to expand our bracket, so we need to multiply negative 1 and what we have here inside the bracket. So we'll have 5 minus 5i times the square root of 3 over 2. Now since 5 is 5 over 1, we need to find an equivalent fraction for 5 over 1. So we'll have 10 over 2 minus 5 minus 5i times the square root of 3 over 2. And now having this, we can find the value of y. So y is equal to 10 minus 5 times I times the square root of 3 all over 2. And now we subtract like terms, so we have 10 minus 5. 10 minus 5 gives us 5, so we'll have 5 minus 5i times the square root of 3 all over 2. So our first solution of y is equal to 5 minus 5 times I times the square root of 3 all over 2. So now let's look at the second solution of y. So we have y is equal to 5 minus the second solution of x, which is 5 minus 5i times the square root of 3 all over 2. So from here we evaluate this by expanding our bracket, so we can see the equivalent fraction of 5 is 10 over 2. So we'll have 10 over 2 minus 5 plus 5i times the square root of 3 over 2. So then from here we have 10 minus 5 plus 5i times the square root of 3, and we have all of this over 2. Now therefore our second solution of y is that y is equal to 5 plus 5 times I times the square root of 3 all over 2. So now we have our solutions for y. So our solutions for x1, y1 is that x1 is equal to 5 plus 5 times I times the square root of 3 over 2. And as we said before, the value of y1 is equal to 5 minus 5i times the square root of 3 all over 2. So this is our first pair of solutions. And for our second pair of solution, where we have x2, y2, the second solution of x is that x is equal to 5 minus 5i times the square root of 3 over 2. And y2 is equal to 5 plus 5i times the square root of 3 over 2. Now from here we can actually verify our solution sets. We can check our solutions by plugging in the values of x and y into any of our equations. So we are going to go with equation 1 and we are going to plug in the values of x1 and y1 into that equation, where we say that x1 plus y1 is equal to 5. So we have the value of x1, and the value of x1 is 5 plus 5i times the square root of 3 over 2. And then from here we can add that to the first solution of y, which is 5 minus 5i times the square root of 3. And that 2 is over 2, so we have all of this over 2. Now from here we can pair our like terms, so we'd have 5 plus 5, so 5 plus 5 would be here, and then we'd have plus 5i times the square root of 3, and it would have minus 5 times I times the square root of 3. And we have all of this over 2. So from here we know that 5 plus 5 gives us 10, and these two are going to cancel out, so we just have 10 over 2. Now we can bring this to its lowest term by dividing both top and bottom by 2. 2 into 10 goes 5 times. So there we have it, our solution is verified using equation 1. Now let us see if we can verify our solution using equation 2. Now equation 2 states that x times y is equal to 25. In this example we're going to use x2 and y2. So we see that the value of x2 is 5 minus 5i times the square root of 3 over 2. So we can have that in brackets, as we are going to multiply the value of y2. So the value of y2 is 5 plus 5i times the square root of 3, and we have all of that over 2. Now if you look at our pairs of brackets, the only thing that is different is that in one bracket we have one being negative and one being positive. If you look closely, this is an example of what we call the difference of two squared, where we have a squared minus b squared is equal to a plus b in one bracket, and in another bracket is a minus b. So I'll be using this example to simplify our equation. So using this example, this means that we'd have 5 squared minus 5 squared, and the I also will be squared, and the square root of 3 will also be squared. And of course, we'll have all of this over 2 squared. We know that 5 squared is 25, so we'd have 25 minus, we have 5 squared again, so we'd have 25 minus 25 again. And we know that I squared is going to give us negative 1, so we'd have 25 times negative 1. And here where we have the square root of 3 being squared, the square will cancel out the square root sign, so we'd have that times 3 as well. So then that means we have 25 minus 25 times negative 1 times 3. And that is also over 4, as 2 squared is 4. Now in having this, we'll use what we call the order of operation. So what that means is that this what we have here evaluates as 25 plus 75 all over 4. Now 25 plus 75 gives us 100, so we'd have 100 over 4. And 4 into 100 gives us 25. And now there we have it. Our solution is verified using equation 2. Thanks for staying tuned with me to the end of this video. I hope that this was very informative. If you like this video, please smash that like button, share and subscribe to my channel for more updates like this. And until then, I'll see you soon. Thank you.